You hold your hand near a candle flame. Heat, you feel it immediately. The warmth radiates from that small point of light, travelling through empty air, finding your skin. This has happened to you thousands of times. Campfires, stoves, matches, lighters. Every time something burns, heat pours out. Obvious, universal, accepted. But here's what's strange. Most people never ask what heat actually is. They know fire is hot. They know it burns. They know to keep their distance. But if you ask what's really happening when you feel warmth from a flame, when you ask what heat fundamentally is, the answer most people give is wrong. Not just incomplete, wrong. Because heat isn't what you think it is. It's not a substance. It's not a thing that flows like water. And fire doesn't give off heat the way you imagine. What fire does is far more beautiful. Fire reveals something profound about the nature of reality itself, about how atoms work, about what energy actually means, and about why you exist at all. When you understand what heat really is, you realize that the warmth you feel from a candle isn't just physics. It's a window into the deepest patterns of the universe. Start here. Wood sitting on a table, not burning, just wood. Dead cells from a tree that grew decades ago. Molecules arranged in intricate patterns, carbon atoms linked together in long chains. The air around it, oxygen molecules, nitrogen molecules, moving, always moving. They've been moving since the moment they formed, bouncing off each other, bouncing off the wood. Millions upon millions of collisions every single second, but nothing's happening. The wood just sits there. The air just floats around it. Nothing changes. Now you light it. A match, a spark. Something introduces enough energy to break a few molecular bonds, to get a few carbon atoms close enough to oxygen atoms that they snap together. And when they do, energy releases. A lot of energy. This is what combustion is. Not magic, not some mystical process. Just atoms rearranging themselves into lower energy configurations. Carbon and oxygen want to be together as carbon dioxide. That's the stable state. But to get there, they need help. They need that initial push. Once it starts, though, it cascades. The energy released from those first few reactions makes neighboring atoms move faster. They collide harder. More bonds break. More carbon finds oxygen. More energy releases. The process feeds itself. This is fire. A self-sustaining chemical reaction where atoms are constantly rearranging, constantly releasing energy. But here's where it gets interesting. Where does that energy go? Most people say fire produces heat, but that's not quite right. Fire doesn't produce heat. Fire produces motion, molecular motion. The atoms and molecules around the flame, the ones in the air, the ones that just formed from the reaction, all of them start moving faster, much faster. They're vibrating more intensely, bouncing around more violently, colliding with each other with more force. And that motion, that frantic, invisible dance of molecules, that is what heat is. Not a substance, not a fluid, not something separate from matter. Heat is the kinetic energy of molecular motion. When something is hot, its atoms are moving fast. When something is cold, so its atoms are moving slowly. Temperature is just a measurement of average molecular speed. That's it. That's the entire secret. Heat isn't a thing that exists on its own. Heat is what we call it when atoms won't sit still. Think about that. The warmth you feel from a candle flame isn't some mysterious force emanating from the fire. It's the kinetic energy of rapidly moving molecules in the air around the flame. Those molecules, carbon dioxide from the reaction, water vapor, nitrogen, oxygen, they're all vibrating and bouncing around at incredible speeds, faster than they were before the fire started. And when they collide with other molecules, they transfer some of that motion. The energy spreads. This is why fire feels hot. The fast-moving molecules near the flame collide with slower-moving molecules farther away. Each collision transfers kinetic energy. The slower molecules speed up. The faster molecules slow down slightly. Energy distributes itself. This process, this transfer of molecular motion through collisions, is called conduction. It's how heat moves through matter, not as a substance flowing, but as motion spreading, one collision at a time. But fire does something else, something even more remarkable. It doesn't just heat the air around it through collisions. It sends energy through empty space. You can feel the warmth of a fire from across a room, through air that hasn't directly touched the flame. You can feel the heat of the sun 93 million miles away, through the vacuum of space, where there are no molecules at all. How? The answer is electromagnetic radiation, specifically infrared radiation. When molecules in the flame move fast enough, when electrons in atoms get excited to higher energy states and then fall back down, they emit photons. Particles of light. Most of these photons have wavelengths in the infrared range, longer than visible light. Invisible to your eyes, but perfectly designed to make molecules vibrate when they're absorbed. This is what you're actually feeling when you hold your hand near a flame. Photons, trillions of them, streaming out from the fire in all directions, traveling at the speed of light. When they hit your skin, they're absorbed by molecules in your cells. The photon's energy converts into molecular motion. Your skin molecules start vibrating faster. Your nerve endings detect this increased motion. Your brain interprets it as heat. But here's what's beautiful about this. And the photons themselves aren't hot. They're not cold either. Temperature doesn't apply to individual photons. They're just packets of energy traveling through space. They only become heat when they're absorbed by matter, when their energy converts back into molecular motion. Heat, fundamentally, is a property of matter in motion, not of light, not of energy in transit, only of atoms and molecules bouncing around. So fire doesn't give off heat in the sense most people imagine. Fire causes molecules to move fast. Some of that motion spreads through collisions with neighboring molecules. Some of that motion gets converted into electromagnetic radiation, into photons that travel outward until they hit something and convert back into molecular motion. The fire itself isn't hot in some absolute sense. It's just a place where atoms are moving incredibly fast and emitting a lot of electromagnetic radiation. Now, why does any of this matter? Why is this more than just a technical description of a physical process? Because it changes how you see everything. When you understand that heat is molecular motion, you start to realize that temperature is everywhere, in everything. The chair you're sitting on right now, its atoms are vibrating. Not as fast as fire, but they're moving. The air around you, every single molecule is zipping around at hundreds of meters per second, colliding with each other millions of times every second. Your body, your cells, every atom in you is in constant motion. That motion is what keeps you alive. It's what makes chemistry possible. It's what allows your neurons to fire, your heart to beat, your thoughts to form. You are, at the most fundamental level, a pattern of molecular motion. And so is everything else. The coffee cooling on your desk is just molecules slowing down. The ice melting in your drink is molecules speeding up enough to break free of their rigid structure. The sun warming your face is photons from nuclear fusion 93 million miles away, hitting your skin and making its molecules move faster. Heat isn't separate from the world. Heat is the world. It's the fundamental activity of matter. This is what Feynman understood. This is what most people miss. They think of fire as this mystical thing that produces heat, as if heat were some sort of ethereal substance that flows out of flames like water from a fountain. But fire doesn't produce heat. Fire is just atoms rearranging themselves, releasing energy that was stored in chemical bonds, energy that manifests as increased molecular motion and electromagnetic radiation. The heat you feel is molecules moving. That's all it is. That's all it ever was. And once you see this, once you really understand it, you start asking different questions. You wonder about absolute zero, the temperature where molecular motion theoretically stops. You wonder why it's impossible to reach, why quantum mechanics ensures that atoms never quite stop moving. You wonder about entropy, about why heat always flows from hot to cold, about why molecular motion always tends to spread out and equalize. You wonder about the beginning of the universe, about the Big Bang, about what it means that everything was once compressed into a point of unimaginable energy, of unimaginable molecular motion. You wonder about black holes, about what happens to heat and molecular motion when space-time itself curves so intensely that nothing, not even light, can escape. You wonder about the heat death of the universe, about the distant future when all molecular motion has distributed itself so evenly across space that nothing can happen anymore, when every atom is moving at the same average speed and there's no energy gradient left to drive any process, any reaction, any thought. Fire becomes a metaphor, a teacher, a demonstration of the deepest principles of thermodynamics, of energy conservation, of entropy, of the arrow of time. Every time you light a match, you're watching atoms obey the fundamental laws of the universe. You're watching energy transform from one form to another. From chemical potential energy stored in molecular bonds to kinetic energy of molecular motion to electromagnetic radiation streaming through space. And the warmth you feel isn't just warmth, it's a message from the quantum world, from the invisible realm of atoms and photons, translated into a sensation your brain can interpret. It's the universe speaking to you in the only language matter knows. Motion, energy, change, the endless dance of atoms that began 13.8 billion years ago and hasn't stopped since. But there's something else, something deeper. The energy that fire releases, where did it come from in the first place? Why did those carbon atoms in the wood have energy stored in their bonds at all? The answer takes you back. 6 months ago, maybe a year, that tree was alive. Its leaves were capturing sunlight. Photons from the sun, travelling 8 minutes across space, hitting chlorophyll molecules. Those photons carried energy. Through photosynthesis, that photon energy converted into chemical energy. Carbon dioxide from the air combined with water from the soil to form glucose. Chains of carbon atoms bonded together with energy stored in those bonds. That's where the fire's energy came from. From the sun. The wood is stored sunlight. When you burn it, you're releasing solar energy captured months or years ago. The heat you feel from a campfire is the heat of the sun, just delayed, time shifted. The photons warming your hands aren't the same photons the tree absorbed, but the energy is the same, just transformed, stored, released. And if you trace it further back, the sun's energy comes from nuclear fusion. Hydrogen atoms in the sun's core keep moving so fast they fuse into helium. That fusion releases energy. That energy reaches the sun's surface, radiates out as photons. Some hit Earth, some hit leaves, some get stored in trees. When you feel heat from a fire, you're feeling nuclear energy from the sun's core, filtered through photosynthesis, stored in wood, released through combustion, converted into molecular motion. You're touching a chain that connects you to the sun, to nuclear physics, to the fundamental forces of nature. This is why understanding what heat really is matters. It's about connection, about realizing that everything is connected through energy, through motion, through these endless transformations that power the universe. The warmth you feel isn't isolated. It's part of a story that began when the sun formed, when hydrogen clouds collapsed and ignited. And you're part of that story. Your body is warm because of molecular motion powered by chemical energy from food, which came from photosynthesis, which came from the sun. You are made of stardust, powered by stellar fusion. The heat in your body is nuclear energy. Many steps removed, but the same energy nonetheless. So the next time you feel heat from a fire, don't just think hot. Think about what's really happening. Think about the billions of molecules in the air moving faster because of chemical reactions. Think about the photons streaming from the flame at the speed of light, carrying energy through space. Think about those photons hitting your skin, making its molecules vibrate, that vibration traveling through nerve endings to your brain, where it becomes conscious experience. Think about the fact that fire doesn't give off heat. Fire gives off motion. And motion is what everything is. Motion is what connects you to the sun, to the beginning of time, to every star that's ever burned. Motion is the language the universe speaks. And heat is just what we call it when that motion becomes something we can feel. What else are we feeling without knowing what it really is?